So is this a graph of function? Why or why not? And explain how you know. So I know that for it to be a function, it would need to have only one y value for each x value. So I'm going to look right here at x equals 0. For x equals 0, I see that y equals -1 and y equals +1. So this is not a function because x equals 0 has two outputs. And they are y equals -1 and y equals, it looks like is approximately +1. It doesn't look like it's totally there, but it looks really close. The graph's domain. So remember, the domain is all of the x values. So it looks like this is a sideways parabola, so it would keep going forever and ever and ever to the left. So the x values would go from -infinity all the way up to, let's see, it looks like it stops right there at +1. Remember, we can't be equal to infinity, so we've got only a less than sign, no equal sign right there. The range of this graph, so it goes all the way, this parabola is going to keep opening up and down. So it's going to go forever down and forever up. So the range of this graph would be all real numbers. Or we could say that the range goes from -infinity to +infinity. Is the graph discrete? So is it a set of points or is it continuous? Which means infinitely many points that make a curve. So this is continuous because many points make the curve. All right, let's look at the next one. So is this one a function? Does each x value only have one y value? Yes. Each x value only has one y value. What is the graph's domain? So the domain is the set of the x values. So we could say that the domain is, let's see, negative, this was at -2.5, and then it's at -1.5, -0.5, +0.5, and then this is, looks like maybe 1.6. We could also write that as a set. So with these brackets, so then the range is all the possible y values. So the y values here will be like, let's see, it looks like 0.9. This one is 1.6, 2, 2.5, and then this one looks like 3. And again, we could also write these as a set. So 0.9, 1.6, 2, 2.5, 3. Is the graph discrete, a set of points, or is it continuous, which is infinitely points, infinitely many points? So this graph is discrete because it only has 1, 2, 3, 4, 5 points. And they're not connected to each other. All right, fill in the chart. So here's the pattern. It goes 8 to 4 to 2 to 1. So this is exponential because each time we're multiplying times 1/2. Remember, multiplying by 1/2 is the same thing as dividing by 2. So here it looks like I'm going minus 10, minus 10, minus 10. So this is linear. The first difference is constant. And we are subtracting 10 each time. Here it looks like we're multiplying by 10. So this is exponential because we are multiplying by 10 each time. So this, let's see, it looks like it's creating a line. So here we go over 5 and up 10, over 5 and up 10. So here the slope is, let's see, we went up $10 and over 5 games. So the slope is the change in y. So that's $10 over the change in x, which is 5 games. So 10 divided by 5 is $2 per game. So this is linear because the slope is the same. The slope is constant at $2 per game. For each function below, find f of 1 and f of -2. So for this one, f of 1 equals 3 times 1 minus 5, which is 3 minus 5, which is -2. So f of 1 equals -2. For the second one, f of -2 equals 3 times -2 minus 5, which would be -6 minus 5. So that's the same thing as plus -5, which is -11. So f of -2 is -11. For the second one, f of 1 equals 5 times 1 squared minus 2 times 1. 1 squared is just 1, so 5 times 1 minus 2, which is 5 minus 2, which is 3. So f of 1 equals 3. F of -2 equals 5 times -2 squared minus 2 times -2. 5 times so -2 squared is -2 times -2, which is 4. So that's 5 times 4 minus -4, which is 20 minus -4 is plus 4. Subtracting is just adding the opposite. So that equals 24. So f of -2 equals 24. And then for the last one, f of 1 equals -4 times the square root of 1. The square root of 1 is just 1, so that equals just -4. F of -2 equals -4 times the square root of -2. This is not possible. There is no solution because you cannot take the square root of a negative number.